physical, physical. I wanna get physical. Let's get into physical.
Good morning. Today we're going to be talking about momentum. Momentum is inertia in motion. The equation for momentum is P, which stands for momentum, equals mass times velocity. Therefore, it seems intuitive that the units are going to be kilogram times meter per second. Kilogram for mass, meter per second for velocity. The conservation of momentum is the total momentum in a system from the beginning to the end. So, if you had a collision between two objects, you have object 1 and object 2, they both have momentum before the collision and momentum after the collision. So to set up an equation, or set up a equation, you would use what we found here, and you would have m1 initial times v1 initial plus m2 initial times v2 initial equals m1 final, or the masses shouldn't change, times v1 final plus m2 times v2 final.
Go.
To add on to the conservation of momentum, the total momentum before the collision, which is this whole equation right here, which is symbolized by the p naught, is equivalent to the total momentum after the collision, which is this equation right here, and is symbolized by the p final. There are two types of collisions, inelastic and elastic. Inelastic collisions, and in an elastic collision, the kinetic energy is conserved. This means that the collision is sticky. A good example of this would be if a football player hits another football player and grabs hold of them, the two masses combine and their velocity is one moving forward. So, this would, an equation like this would be, again, you would have mass 1 times v1 initial plus mass 2 times v2 initial equals the combined mass, which is mass 1 plus mass 2, times the combined v final. With momentum, the mass of the object and the velocity are inversely proportional. So you have your regular equation here, your most basic equation, which is P equals mv. If you have a small mass, which would be little m, and a big, if you have a small mass, you'd have a big velocity, which would equal the same, could equal the same momentum as having a big mass and a very small velocity. Therefore, they're inversely proportional.
Hello, class. Alright, so we're going to do two types of collisions right now. First, we're going to do an inelastic collision, where my car and Harry's car will be approaching each other. Harry's car is going to be going a little bit slower than mine, and then my car is going to hit Harry's car, and they're going to stick together and go back towards Harry.
Is it going to be going slower because I'm not as strong as you?
Yeah. 1, 2, 3.
Inelastic!
Alright.
Momentum is always conserved. In this situation, the momentum of the car, this car, is canceled out slightly by the momentum of this car because it has a negative momentum. However, as they go this way, momentum is conserved. Kinetic energy, however, is not conserved. Kinetic energy is lost to heat, sound, and the cars being squished and stuff like that.
Different from inelastic collisions because the kinetic energy in an elastic collision is not conserved. So KE is not conserved. This means that the collision itself is bouncy. So, an example of this, or when KE is not conserved, so therefore the energy comes off in heat, or other different forms of energy, like sound. An example of this is when if you're playing like bumper cars, you have one bumper car hits the back of another one, stops moving, and the next one continues going. So the equation for this would be, you have m1 v1 initial plus m2 v2 initial equals m1 v1 final plus m2 v2 final. And in this, generally, one of the...
Hello, class. We'll now be looking at elastic collisions. So in an elastic collision, the two objects bounce off each other, and the KE is conserved in the system as well as the momentum. So here we go. This
That
did
didn't
not
work
work.
out well.
Alright, so as you can see, the initial speed of each car is replicated in the opposite direction after they make their collision.
Impulse, which is a concept closely related to momentum, is simply the change in momentum. Just change in P.
What?
So an equation that's commonly used with impulse is I equals force times the change in time. Units for this are Newton seconds. The other equation for impulse is mass times change in velocity. This impulse is the change in momentum. An example of this is when an egg is dropped on the pavement, the time is very small, so that its collision with the pavement is very small, so therefore the force is going to be very big. So in that situation, you have I equals big F and very little t. However, if you ever see, like in movies, someone jumping out of a window onto a mattress, the time of the collision is due to the mattress is much longer. So in that scenario, you would have impulse equals a very small force times a very big t.
In this demo, we're going to be talking about impulse. Impulse is the change in momentum. So impulse is usually seen as force times time. In this demo, you're really going to see what the difference between change of force over change in time is going to do to a mass, aka this egg. So this line into this bucket of fur, you're going to see that the egg will not break. Ready? Egg's intact. But as I drop it from this height without the fur, egg breaks. The reason for that is it's the same impulse, same change in momentum, except when I drop it into the fur, it's a smaller force over a longer period of time. You know, it cushions it down. It's the same reason why when you drop a plate on carpet it doesn't break, but when you drop a plate on the ground, it shatters. See here, it's bigger force, shorter time. But the important thing to notice is that they have the same exact impulse. Fini.